Okay, now we're on number 6. All right, if you're following along in the book, we're on page 360. And let's read number 6. It says, write each of the following fractions as a terminating decimal or if a repeating decimal. And then it says rounded to the nearest hundredth place. So the way I interpret that is that no matter what, we got to round to the nearest hundredth place. So let's go ahead and do that. Let's use lime, shall we? All right. So we have 5/8. Here, I'll number it for you. 6A, and we're looking at 5/8. So we're going to change that to a decimal and then round. Well, 8 goes into 5 how many times? It goes into 0 times. We put a point there. And there's an infinite amount. There's technically an invisible point here that we never really use when you're using a whole number, but there's really a point right after that 5. And then we can have as many zeros as we want after that. So 8 goes into 5 0 times, so we put a point there, and then we add in that 0 that's already there, but we just reveal it. All right, and then 8 goes into 50 how many times? Well, that's 6 times. And then there's a 48 here, and then we do the subtraction, and we get a 2. And then we add a 0 to that. How many times does 8 go into this? Well, that's 2 times. And then we get a 16, and then we subtract, and we get 4. And how many times does 8 go into 40? All right, we're bringing down zeros, by the way. See, there's a 0 here, and there's a 0 here. We just revealed them, brought them down, revealed this one, brought this one down. How many times does 8 go into 40? That's 5 times. So technically, it is 6. Oops. Technically, it is 0.625, but we're going to round to the nearest hundredth place, which is right here. So when we round to the hundredth place, we look at this number right here. Is it greater than or equal to 5? It is. So the answer is really 0.63. That's the answer. All right, let's go ahead and look at B, 6B. 6B. 6B is 47 over 1,000, like so. Now, I don't even think I'm going to use long division here. I'm just going to use good old common sense. We know that based off of what we learned before, that say we have like 25 over 100. All right, this is not part of this problem, but I'm showing this to emphasize what I'm going to do here. I'm leading to what I'm going to do here. So what is this? Well, anything over 100 is 25%, right? All right, 25% can be rewritten as 25 over 100, okay? 25% can also be rewritten as 0.25. Now, how do we write it as 0.25? Well, the reason we write it as 0.25 is because when we have something over 100, we just take the decimal, which is right here, which we usually don't use. We reveal that decimal, and then we take that decimal and move it back 2 places, which puts a decimal here, which gives us that 0.25. Which brings me back to here. Right here is 47 over 1,000. Well, it's 1,000. There's 3 zeros, 1, 2, 3. We move it back, just like we moved 2 zeros, right? Or, say we have like 7 over 10. We move the decimal back 1. So it's just 0.7, you see. We move this back 3 decimals. So it's 1, 2, 3, right here. So the answer to this one is 0.047, like so. You see, like that? Now the question at hand is, what is it rounded to the hundredth place? Well, when we round to the hundredth place, we round to the second place value right here after the decimal, and it's currently at 4. But we look at this number here to the right of it, and is that greater than or equal to 5? It is. So the answer is 0.05. That is the answer, ladies and gentlemen. All right, 6C. 6C. Hopefully you're following along. Again, we're on page 360 if you have your book. And we're looking at 20 over 33. Well, 20 over 33, what is that? Okay, well, let's see here. We have to do long division here, and we write it like so. Does 33 go into 20? No, it doesn't, so put a 0 there. We put a decimal here. We add a 0 there. How many times does 33 go into 200? Well, if I round down to 30, I have something that is more easily managed. So 30 times 6 would give me 180. 30 times 7 would be 210, right? I'm using my times tables. 3 times 7 is 21. 3 times 6 is 18, but I add a 0. So I'm going to guess 6. So let's do 6. Oh, not there. 3, 3, and then 6 below, and then 3 times 6 is 18, add a 1 here. 3 times 6 is 18, then add the 1 to the 18, so it's 198. There we go. So it's 6 right here, 198 here, and then we do the subtraction, we get 2 here. Oh, that's something that we had before, 20. Does 33 go into 20? No, it doesn't. We already added a 0. We already brought down a 0. See, there's another 0 right there. Right, there's the decimal place, went there. We added that 0 before to get the 200. Then we had this 0 that was already there, just revealing it. Again, we've gone over this. Brought this down. Bringing 1 0 down still doesn't make it big enough for 33 to go into it, so we have to bring down another 0. And now we're at 200 again, and we know that 6 is going to give us this. And then, we're at 20 again. Oh, goodness. So then that's 0 again, and then we add another 0 to that, and that's going to be 6, although I ran out of room. But basically, this would be 6. Oops, that's kind of ugly. Let's try that again. It would be 6, 0, 6, 0, 6, 0. And so we round to the nearest 100th place, which is right there. And we look at that, and that's bigger than 5. 5 or bigger. It's greater than or equal to 5. So the answer is 0.061, like so. All right, let's look at 6D. 6D is negative 19 over 25. All right, negative 19 over 25. So we put the 25 here, and we put the 19 here. And I'm not going to deal with the negative right now. I'm just going to remember that it is, circle it, and I'll just remember that I need to make it negative in the end. So 25 goes to 19 0 times, add a 0 here. Okay, and decimal right there. Remember there's this invisible decimal that we usually don't use right there. Bring it up. How many times does 25 go into 190? Well, 25 goes into 100 4 times, so 25 goes into 200 8 times. So how about 7 times? 25 times 7. That's a 35 plus a 3. And that equals 7 times 2 equals 14, plus the 3 to it is 175. We can't add anything else to that. We can't times it by 8 because that would give us 200, so it's too big. So let's just stick with that right there. So put a 7 there, 175 here, and then we do the subtraction. Right? So let's go ahead and do that. We subtract, and what are we going to get? We're going to get, well, first off, we need to take that, make it an 8, and we need to make this a 10, right? And that turns into a 5, and this turns into a 1. So we have 15. Does 25 go into 15? Well, we need to bring down a 0 right here, first off. We can't. I shouldn't ask if 25 goes into 15. I should have brought down the 0 first. Now, does 25 go into 150? Yes, 25 does go into 150. How many times? Well, I would imagine it goes into it 6 times, but let's just double check. 25 times 6 is, well, 5 times 6 is 30. Bring the 3 here. And then 2 times 6 is 12, plus the 3, which is 150. So that's, when we do the subtraction equals 0, so the answer is 0.76. And we just stop there. We don't need to round because we already are in the 100th place. All right, so now, based off of the review, we need to, let's take a look at the review. What's after 6? We need to do 7A through D. All right, 7A through D. Let's do it. Round that number. All right, let's write that number out real quick. So let's change colors. Let's do cayenne, red. All right, so 7. Let's write the number first. Actually, I don't like that color. Let's use a different color. Let's use this one. All right, so the number we have is 692, 895.09 8, 4, 4, and then a 2. All right. Just 1 second, I received a text. All right, so we're going to round it to the 100th place. According to what we have here, 7a, we need to round to the 100th place. So what is 100th place? 100th. Emphasize the th at the end, 100th. So we need to round to the 100th place. Well, that's going to be right here. All right? We need to round to this number. So we look at this and we go, okay, now, what is this? Is this greater than or equal to 5? It is. So we round this 9. We got to round it up. And when we round it up, we have to make the number like this. I'll show you. So let's get rid of that real quick. And so now it's 692, comma 895 point, and we have to make it like this. This is to 100th place. Making this 9, rounding this 9 up makes this a 1, and then we just leave the 0 because it says 100th place. So we keep this 0, even though 0 is not needed. We still keep it because it says to the 100th place. All right, 7b. All right, 7b says that we need to round to the 1000th place, right? So the 1000th place would be right here. No, 1000th. Oh, thousandths. We got to remember the th, so it's right here. So we got to round to this place. So we look at this number. Is this greater than or equal to 5? No, it's not. So then it's just this number. So it would be 692, comma 895.098. And that's it. 7c. 7c is to the 10th place, so it's right here. Okay? To this place right here. So when we round to this place, we look at this number right here to the right of it, which is a 9. That's greater than or equal to 5. So we round this to 6. We round it like this. We write it like this. 692.895.1. All right? That's the 1000th place. I mean, sorry, not the 1000th. That's the 10th place. So far, we've rounded to the 100th place, the 1000th place, and the 10th place. Now let's look at 7d. 7d tells us to round to the nearest whole number. Well, the nearest whole number is right here, just the 1. Right, the 1 place. So we look at the 5. We look to the number to the right of the 5. Is that number, which is 0, greater than or equal to 5? Well, it's not greater than or equal to 5, so we just keep this number. So the answer to 7d is 692.895, like so. And that is 7. So now let's go to the next one in the review. The next one in the review that we need to do is 8a. 8a, here we go. So it says rearrange the following groups of decimal numbers in order from smallest to largest. All right, let's go ahead and do that. So 8a. Well, sometimes it helps us to have the same number of same number of numbers after the decimal, after the decimal point. So let's write the numbers out, and let's use the same numbers. So the number with the most decimal places, or the most numbers, is I think the 5th number over, and I think the 6th number as well, and that has 5. So let's make sure this has 5. So we have 4 like this, 7, 8, 0, 0. Oops, 8, not 5, 8. Like this, 0, 0. That's the first number. And you know what we could do is we could line. Oh crap! We could line them up like this. So 4.78. All right, and then we could add 3 zeros. 0. And then the next one is 4.00. 4.0078, and we can add another 0, so it's 5 digits, 5 place values. And then we can write this one as 4. Oh, hold on, did I skip one? Let me see here. No, I'm good. 7, 0, 8, and then 0 again. And then let's write this one as well. 0, 0, 0, 7, 8. And then the last one, 4.07008. All right. If you write them vertically like this, it also kind of helps to, it also allows you to see which one's biggest. So we can go from left to right, and we got a 4, they're all the same. 0, 7, that's bigger. So this is the biggest one right here. So, you know, if on the test you had to do something like this, you could call this one, you know, like the first. You can do this first number, right? Because it's from smallest to largest. My bad. That would be the last one. So we gotta find the smallest one actually. So here let's keep going. So, all right. So these two are smaller than the rest of these. So let's look at these two. All right, these two are small. These two are the smallest. I would have to say this one's the smallest. So this would be the first one. So you could either put this as first or you could rewrite it again. So this one's now like so. All right, that's from smallest to largest. That's the one we want to use right there. That's the smallest one. Okay. Then I would imagine that so I can cross this one out. So now let's look at them again. Let's see here. Here's a 0, and here's a 7, and here's an 8, and here's a 7 right here, and here's a 7 here. So the next smallest one would be this one right here. So it would be 4.0078. All right, and then we could add the other 0 if you wanted to. Cross that one out, and then let's look at it again. So we have place values here. We have 7, 8. So this one's going to be bigger. We have 7, 7, 7. All right, so 7, 7, 7. So here's a 7, and here's an 8. And here's a 7. Here's a 0. So that's 8 is bigger than 0. So it's these ones down here. So 7, 0, 7, 0. All right, they're the same. 7, 8, 7, 0. So I have to say this one's probably the biggest one right here. I mean, the next biggest one. So it's this one right here. All right, and then after that, it's this one right here, 4.07080. And then finally we get up to here, and we look at these first two digits. This is the next one right here. And then finally, this one is the biggest. And you don't have to do it vertically like this if you don't want to. You can leave them horizontal. This sometimes helps to line it up to see which one is the biggest this way. But it's up to you. Sometimes I do it I don't rewrite it like this. Sometimes I just look at it. I look at the horizontal view, and I can do it that way too. All right. Let's go ahead and do the next one. The next one on the list is 9, and then we're going to do 9A through C, then F through I, then L through M, and then R through U. All right. Hopefully you're paying attention. Let's move forward. Here we go. (9A). What we're going to do is we're going to take 14 and 5 sevenths, and we're going to do plus 10 and 2 sevenths. All right. So since they have the common denominator, the 7 to 7, this is pretty easy. We take 14 and we do the integers first. 14 plus 10, that's 24. And then 5 plus 2, which is 7, and then over 7. So it's really just, and we can write like this, even though normally we don't have to write like this. In this case, it might be good to write like this. So that turns into 24 plus 1, which is just 25. Okay? All right, the next one, B, 9B. 9B is 12 and 1/9 plus 7 and 5/9. All right, So what we want to do is we want to take the 12 plus the 7, and we get a 19. And then we want to take the 5 plus the 1, and we can do that because the 9s are the same. They share a common denominator. And so that turns into 6 ninths, like so. Alright, and then we can reduce the 6 ninths. 3 goes into both of those. And so we could change this to 19 and 2/3. Alright, let's continue forward. Next one is 9c. Let's erase this so we have room. Alright, 9c. 9c is 13 and 5/6 plus 10 and 7/8. This one's slightly more difficult because they don't share a common denominator. But we still want to take the 13 plus the 10, which is 23. And then we want to take the 7 plus the 8. I'm sorry, the 5/6 plus the 7/8. And they don't share a common denominator, but what is a common denominator here? Well, it's 24, right? 6 goes in 24, 8 goes in 24. So we need to times this and this by a number that gives us 24 and have the same, have an equivalent fraction. Well, that's going to be 4, so it turns into 20 over 24. And then this turns into 21 over 24 because we times both top and bottom by 3. So then what we get is we get, oh goodness, that's quite a big number actually. We get 41 over 24. And see, this is an improper fraction, so we can't have that, so we need to figure out how many times 24 goes into 41. And so we do 24, we do long division, like so. And does it go into 4? Does it go into 1? No, it doesn't. Does it go into 4? No, it doesn't. Does it go into 41? Yes, it does. How many times? 1 time. It's not going to go into it 2 times because that would be 48. So 1 time, put a 24 down below, and then do the subtraction. This turns into a 3. This turns into 11. This turns into a what? 7? Yes. And this turns into a 1, so it's 17. So then we add this quotient, which is 1, to the 23, which is over here. So that turns into a 24. And then we take this number right here, which is the remainder, we make that the numerator, and then the 24 is on bottom. And that is the answer. It's 24 and 17/24. All right. I know it seems a little complicated, but I'm sure you'll be able to do it when it comes to the test. All right, next one. It's going to be 9. We got to change pages. All right, so now we're on 361, and we're doing 9F through I. So let's go ahead and do that. 9F through I. So here's 9F. Let's change colors too, shall we? 9F. It's 3 and 5/8. Right? Plus, oh no, that's the wrong one. I'm looking at the wrong one. Sorry about that. It's actually, so 9F. It's actually 23. 23 and 11/13 minus 12 and 9/13. So when we do that, we take 23 and we minus the 12 from it, which gives us 11. And then we take the 11 and we minus the 9 from it. Why can we do that? Because 13 and 13, same common denominator, so that turns into 2/13. All right. Next one, 9G. 9G is 4 and 1/3 minus 2 and 1/6. So we can take 2. We can take 2 away from 4, so that turns into 2. And then we're dealing with 1/3 minus 1/6. Oops, that doesn't look right, does it? 6. There we go. All right. The common denominator is 6 in this case, so this turns into 2 over 6, like this, minus 1/6, which just gives us 1/6. So the answer is 2 and 1/6. All right, that was for 9G. I'm running out of room, so Let's delete all that, and now we're doing 9h. 9h, that's 10 and 4/5 minus 4 and 9/10. Well, we do the integers first. We can do 10 minus 4, which is 6. Okay. And then we have 4/5 minus 9/10. We can make, the common denominator here is a 10. So we can times top and bottom by this, we can times top and bottom of this by 2, which turns into 8. So we'll say 8/10 minus 9/10. And that's going to give us a negative 1/10. Well, see, this is a positive 6, and we have a negative 1/10. So basically now it just turns into a subtraction problem. So we could rewrite this 6 as 5 plus 1 minus 1/10, which could also be rewritten as 5 plus 10 over 10 minus 1/10, which gives us 5 and 9/10. So there's the answer right there. And we can't reduce it any farther. All right, let's go ahead and look at 9i. 9i is 8 minus 3 and 2/3. So we have 8. We don't have a mixed number next to it, so we could rewrite 8 as 7 plus 3/3. Why are we doing that? Because this is really, basically, we could also rewrite this as 8 minus 3 minus 2/3. Oops, minus 2/3, you see? It's really 8 minus 3 minus 2/3. So that's 7 plus 3/3, now 8. Now we can minus 3, oops, make that bigger 3. 3 minus 2/3. Now 7 minus 3 is 4. 3/3 minus 2/3 is 1/3. Everything's positive, everything works. We're good to go. All right, let's move on to the next problems on 9. And we're going to be doing 9L through P. So let's make some room. 9L. All right, 9L is a negative 5 and 5/9 plus a negative 8 and 5/6. All right, well that's just really negative 5 and 5/9 minus 8 5/6. So when we have two negatives and we're taking a negative away from a negative, we're minusing, in this case it's negative 5 minus 8. We're really just adding them, so that just turns into negative 13. And this is a negative, this is also a negative 5 really, so it's a negative 5 5/9. It's a negative 5/9, right? And we're going to be minusing 5/6 from it. Well, the common denominator here is, in this case, let's see here, 9 goes into 8, that's 18. So we take this and we times this by 2, top and bottom, that turns into a negative 10 over 18. And we can times this by 3, so this turns into 15 over 18, top and bottom. 6 times 3 is 18. All right, and so then that turns into a negative what? A negative 25 over 18, which is an improper fraction, so we need to change that. So 18 goes into 25 how many times? All right, it goes into it once, 18, and then make that a 1, make this a 15, that's a 7. So this is all negative, right? So now this 1, it's really a negative 1. All this is negative. Remember, we had a negative 25 18ths. So that's really a negative 1. So that's added to the negative 13. So that's negative 14 now. And then the 7 becomes the 7, which is the remainder, becomes the numerator, and the 18 remains the denominator, which is that right there. So it's negative 14 and 7/18. All right, next one. Next one is M, 9M. 9M is 6 and 3/8. All right, and we're going to be minusing a positive 8 and 1/6. Well, that just really means minus, right? So it's 6 minus 6 and 3/8 minus 8 and 1/6. Okay. Well, that gives us a negative 2, and then we're dealing with a positive 3/8, and we're minusing oh, sorry, this is not 8th, this is 6th. This is a 6th. Sorry about that. Let's use a different color to make sure that it's understandable. That's a 6. It's 1/6. Okay. All right, let's move forward. So it's minus 1/6. Well, what's the common denominator here? It's 24. So we times both top and bottom of this to make this an equivalent fraction with a denominator of 24, and we do the same thing here. So this is going to be times 3, so it turns into 9 24ths minus 4 24ths, which gives us, oh goodness, that's a positive 5 24ths. Well, see, the problem here is we have a negative 2 and we have a plus 5 24ths. 24ths, oops. Sorry about that. It's 24. So now we have a negative 2 plus 5 24ths. So we have a negative and a positive. We can't have that. We have to have them both have the same sign. They both have to share the same sign. So we could rewrite this negative 2 as negative 1 minus 1, and we can make that negative 1 really negative 24 over 24. And then when we plus the 25 there, I mean not the 25, when we plus the 5 to the 24, we're going to get a negative 19. So that equals negative 19. And now over 24. So now that works. Now we have a negative 1. This turned into this right here. So the answer is just negative 1 and negative 19 24ths, which can be combined to just negative 1 19 24ths. So that's the answer right there. All right, let's go ahead and do the next one, which is n. No, yeah, n. We gotta do n. And n is 10, so we're doing 9n. N is 10 and 5/9 minus a negative 4 and 3/5. Well, when we have two negatives, we really have positive, so it's really 10 and 5/9 plus 4 and 3/5. So that turns into a 14 because we're plussing the integers first, and then we have 5/9 plus 3/5. Well, what's the common denominator here? Well, the common denominator here, I think, is just the product of the two, 9 times 5, which is 45. So I got to times this and this by 5 to get that 45, so that turns into 25 over 45. And then this is 27 over 45. Then when we plus those together, what do we get? Well, 27 plus 25, that equals 12. Add a 1 there. Oh, that's 52. So now we have just slightly too big of a number. So I gotta use long division to figure out what the mixed number would be, because right now we have an improper fraction. Goes into it one time, 45 here. Change this to a 4. Change this to a 12. It turns to a 7. So the answer is 1 with a remainder of 7. So we add that to the 14, so that turns into 15, and then 7 over 45. And we can't reduce it any farther than that, and so that is the answer for 9n. Alright, let's do the next one, which is O. O. 9n, now we're at 9O. Let's change colors too, shall we? Let's change it to black, shall we? 9O. Alright, 9O is negative 11 and 5/9 plus a negative 1 and 7/12. Okay. Well, when we plus a negative, we're really minusing it. So it's negative 11 minus 1, negative 11 and 5/9 minus 1 and 7/12. So we do the integers first. So it's negative 11 minus 1, which is negative 12. And then it's negative 5/9 minus 7/12. Well, in this case, what could go into both of those? 12, some of the factors, some of the multiples of 12 are 12, 24, 36. 36 will go into both of them. So we times this and this by 3 and this by 4. This turns into negative 20, 36 minus 21, 36. So that gives us negative 41 over 36. That's an improper fraction. We can't have that. So we need to do long division. Put the 41 here. We remember that's a negative, but we don't need to put it up here for right now. Goes at one time, 36 goes underneath. We do the subtraction, and we get a 5. So we have 1 with a remainder of 5. Again, this is a negative 1 because we're dealing with a negative. So it's a negative 1 with a remainder of 5 over 36. So we add that to the 12. So it's negative 12 minus 1 and 5/36, like so. This just turns into negative 13, 5/36. That's as far as we can go because 5 is a prime number. 5 doesn't go into 36. If it was like 35, then we could reduce it, but we can't. So we're stuck with that. So again, that's the answer, negative 13 and 5/36. All right, let's go ahead and take a look at 9R through U, and then we'll finish with this one. This is the second part. We'll finish with this one, and then we'll do a part 3 after that. But we'll finish with part 2 after. We'll take a break, and then go on to part 3 later on. All right. So 9R. 9R. Oh, these they're actually starting to get easier now. So it's 4 over 9, and we're going to multiply it by 15 over, what is it, over 14. Well, I say this is easier because we can do some factoring now. This is really 3 over 3. I mean 3 times 3, I'm going to say. And this is 3 times 5. And this is really 2 times 7. And this is really 2 times 2. So we can cancel out a 2 here and a 2 here. We can cancel out a 3 here and a 3 here. So what do we have left? We have a 2 and a 5 on top. And we have a 3 and a 7 on bottom. And what is one of those negative? Oh, this is, by the way, this is a negative. Negative 15 over 14. So now what we have on top is we have a 2 and a 5, which is 2 times 5, which is 10. And on the bottom we have a 3 and a 7, which is 21. And it's a negative. So it's negative 10 21s. Next one, 9S. 9S. We have 2 and 4/5, all right, divided by 2 and 1/10. We got to change it to mixed numbers, so it's mixed numbers now. We got to change it to an improper fraction. 5 times 2 is 10, plus 4 is 14/5, and then divided by 10 times 2 is 20, plus 1 is 21/10. Now when we divide by a fraction, we have to actually times this number by this number's reciprocal, so it's actually 14/5 times 10 over 21. Well, what is 14? That's 2 times 7. And maybe it would help you to understand this. Before I start factoring things out, I'll show you something. So this is 2 times 5, right? 10 is 2 times 5, really. 5 is just 5. 5 times 1 or 5, and this is 3 times 7. So basically, it was 14 times 10 over 5 times 21. That's what we had down here. All right? And then the 14 turned into 2 times 7, and then the 10 turned into 2 times 5, right? So it's 14 times 10 is the same as 2 times 7 times 2 times 5. And then 5 times 3 times 7. That's what basically is going on. And then what you want to do is you want to start canceling out, like numbers that are, they're shared on top and bottom. So 7 is on top and 7 is on bottom. 5 is on top and 5 is on bottom. So what we have left is we have two twos on top, and we have a 3 on bottom. Well, that makes a 4 over 3. Now, I don't believe they want us to leave it in improper fraction form, so we need to take that and change it to a mixed number. So how many times does 3 go into 4? It goes into it once, and what's the remainder if you minus that? What's 4 minus 3? Well, that's 1, so it'd be like this. It kind of skip some steps, but that would be the answer. The mixed number would be 1 1/3. All right, let's go ahead and take a look at t, 9t, and we're 9t is negative 3 and 1/8. All right, and then we're going to be timesing 2 and 2/7. All right, so change these to improper fractions. This changes to 25 over 8. It's a negative 25 over 8, and this is a negative 2/7. And then this changes into 7 times 2 is 14, plus 2 is 16. Right? Yeah, 16. Negative 16 over 7. All right. Now, we can cancel out the negatives because there's 2 negatives make a positive. And then what is 16? Well, that's 2 times 8. So we can cancel out the 8 here and the 8 here. So then what's left on top? A 25 and a 2, which gives us 50. And what's left on bottom is a 7. Then we ask ourselves, how many times does 7 go into 50? Well, I know 7 times 7 is 49. And then 49 minus 50 would be 1, so it's 49 and 1/7. All right, long division, you'd be able to figure that out too, but I'm just skipping some steps to save some time. So now, the final one before we finish part 2 is 9u. 9u. That's a negative 4 2/3 divided by 1 1/6. Change both these both these mixed numbers to improper fractions, and we get first 3 times 4 is 12, plus 2 is 14, so 14 over 3. It's a negative, and then we're dividing it by 6 times 1 is 6, plus 1 is 7, 7/6. And then what we need to do is we need to flip this one. Right? It's called timesing by the reciprocal, so it's negative 14/3 times 6 over 7. And what is 14? That's really 2 times 7, so we can cancel out a 7 here and a 7 here. And what is 6? Well, that's really 2 times 3, so we can cancel out a 3 here and a 3 here. And what's left on top? A 2 and a 2. And what's left on bottom? Well, nothing. And then we have a negative as well. So this turns into just negative 2 times 2, which is negative 4. And so that is the final answer. And again, like I said, we're going to stop here. This video has been going on for quite a long time now, and we'll just take a break, and then we'll come back and do part 3, and then maybe even a part 4 as well. And then, of course, if you have any questions following these videos, you can always contact me, and I'll see what I can do to help you.